So you have studied about the number systems? Okay, anyways, so let us understand what we will be, what is the course objective is understand types of digital logic, digital circuits and logic families. Now here there are two logic circuits, your combinational logic circuit and sequential logic circuit. So we will be analyzing, designing and implementing the combinational logic. So this implementation part will happen in lab. Okay, so we will be doing the analyze and designing in the theory class and then implementation as lab or might be some simulation software. Similarly, for the sequential, we will do the same thing, analyze, design the sequential logic circuit. Okay, then we develop a digital logic and apply it to solve a real life problem. Like you have counters, you have digital clocks. So how do I make all these digital clocks? Okay, so your actual implementation in electronics starts with this particular subject. Okay, so you need to be very careful when you learn this subject, because unless you learn this particular subject, your mini projects you have in third semester mini project, this time they have included. So all your in mini projects, you can select circuits from this digital circuit design and you can make some application. Okay, like you can make a traffic light signal or you can make a burglar alarm. Okay, so this all concepts of digital over there. Then the fifth and sixth is little bit theoretical. You classify different types of memories and programmable logic devices and simulate and implement basic combinational and sequential circuits using your Verilog HDL. So this is the tool that you will be studying, Verilog HDL. Okay, so this is a simulation tool. So with this, you can do the programming part. So these are your 5 course outcomes. Now, what is the, code, that was your course objective. Now, what are your course outcome? Now, when we make the course outcome, no, this was your course outcome only.
Yeah, this course outcome.
Not changing, what happened? Oh. The first chapter in this syllabus is your number system and codes. It's a 4 hours. Now, this 4 hours actually is very less if we solve numerical. So I will be giving you the problems. So what we are studying in number system, we will be starting with this chapter tomorrow actually. So we will be studying review of binary number systems. So basically 4 number systems we are studying. So review of the binary, the octal, decimal obviously, and hexadecimal number system, and interconversion. Now this is important. Interconversion means suppose I give you 10, number 10, or suppose number 12, okay, which is in decimal, which you have been studying since your childhood, the number system, there's a 1, 2, 3, 4, and so on. So that is your decimal number system. So computer understands things in terms of ones and zeros. Okay, you have to convert it, any representation in terms of ones and zeros. So that's why we need to study binary, octal and hexadecimal number system. Now suppose I give you a binary number system and I want you to convert it to another representation, that is either a octal or a hexadecimal. So this conversion is very much required. Okay, now if you have your calculator, already in calculator, there are buttons where you can directly convert binary to hex, hex to octal, decimal, and so on. Okay, so for verification of the numerical that is given to you, you can use your calculators. But when in the question paper, we give you a particular problem like convert so-and-so binary to octal number system, it will be of 2 marks or 3 marks. You need to write down the steps. What will happen if you directly solve in calculator, you get an answer directly, you write the answer, but that doesn't give you marks because all the examiner knows that in all your calculators, this conversion, interconversion is already there. Okay, so you need to do the steps and the examiner will give you marks only seeing your steps. Okay, you can verify the answer from your calculator if some mistakes you have done in the conversion process and all. Then we will be studying the binary code, the gray code and the BCD code. So here we will be studying 2 codes, basically the binary code and the BCD code. Then some binary arithmetic, like if I'm adding in binary number system, if I'm adding in octal number system, like how you add in decimal, like if it is exceeding 10, you take that carry and then you add. So similarly, how do I do that? So here we are dealing with only 2. That is addition and subtraction using the ones and twos complement. There are many complement form, but nines complement bhi hai, tens bhi hai, but we will be using ones and twos complement. So you will add two binary number using ones complement. So what is ones complements, twos complements, I will teach you. And then how do I add using ones or subtract using ones and twos complement. So this is your first chapter, and you can see the weightage, the number of hours given to this particular chapter is 4 hours. Okay, so usually 4 into 2, that is 8. So in your term and out of that 80 marks question, or you can say 100 marks, 120 marks, 8 to 10 marks will be from this particular chapter. As such, no theory is asked. They will not ask you what are the steps of binary to octal conversion. They will directly give you a number and you have to solve it. They will give you something, you have to add or subtract using whatever, ones complements, twos complements. So very easy to score 8 to 10 marks from the first chapter. Is it clear?
Yeah.
Okay. The next one is the logic family and logic gates. Again, it is 4 hours. So here two sections are there. So difference between analog and digital signals. What are the logic levels? That is your TTL and CMOS logic families and their characteristics. So a little bit of theory. So this already you will again study, like you might have studied what is an analog, what is a digital signal, but still we will be covering it. Then logic level, like we say logic 1 or logic 0. So abhi ye kya hai logic level? Like what is, because for us 0 means a particular voltage for electronics engineers and 1 means a particular voltage. So what is considered as logic 1, logic 2? Now when I say logic, there are two families that are involved. Okay, so your TTL logic hai, and recently since your VLSI has come into picture, so we have the CMOS logic families. So for both the logic families, agar maine bola 1 hai, so for TTL, what is 1? And for CMOS, what is considered as 1? So it is different for both the logic families. So 2.1, you can consider a little bit of theory. Okay, so again, it is of 2 hours. Okay, that is sufficient. Now, set 2.2 comes your digital logic gates. So here, there are various logic gates that you will be studying. Jaise I'm adding two operations, so that is called as OR. If I'm multiplying, that is called as AND. Okay, so then if I am doing the reverse, that is inverted. Okay, 1 ka 0 ho jayega, 0 ka 1. So it is an inverter logic. So various digital logic gates are there. So these are basically ICs that you will be studying and the function. So if they give inputs, what will be the output? So that is logic gates. Now your two logics are only there, 0 and 1. Okay, and combinations of this 0 and 1 we give to the input. What should be my output? Now there are many logic gates. If you see 2.2 digital logic gates. Okay, so there are many logic gates. Suppose I don't have all these logic gates with me, then I cannot implement a particular subject, circuit. So what I need to do is we have something called as universal gate. Now what is universal gate is, using those gates, there are two universal gates. That is, the next one is called as NAND and NOR. So using those two logic gates, I can implement any function. So suppose I don't have AND, OR, NOR, XOR, forget it. If I have NAND and NOR, it is an IC. Okay, it's an IC. So using this NAND and NOR, I can realize any function that is given to me. Okay, so these are universal gates. So initially you will study what are the different digital logic gates, how they are represented, their symbol, like you know how a diode is represented. Okay, how resistor, how do you draw, an inductor, how do you draw? So similarly, note down the notation, how do they look like, the symbols, what is the function, if I give a particular input, what is that output. Then you will study NAND and NOR, that is the universal gates, and then you will realize all functions using NAND and NOR. Okay, so this 2.2 is one part of 2.2. The second part of your 2.2 comes your Boolean algebra and De Morgan's theorem. I don't know whether you have studied it in school, but यहाँ पे you will study algebra. So some formulas are there, जैसे A into A क्या होगा, A into 1 क्या होगा, A into 0. Initially it looks simple, but then there are many such formulas. So you have to remember those particular formulas. That is your Boolean algebra, and then the De Morgan's theorem. So he has given a particular theorem. So based on that, we will be solving some particular problems. Like I'll give you a function, and then you give me the reduced form. Reduced कैसे करोगे? Boolean algebra के जैसे a to 0, you know that comes out to be 0. Anything multiplied by 0 is 0. Anything multiplied by 1 is 1. So all this algebra are there. Still, there are many such formulas. So this 2 hours is not sufficient over here. We will be requiring more number of hours over here. This 2 hours in 2.1, we can try finishing it in 1 hour. And here at least we require 5 hours in 2.2. So that we will make up, because at least I need to take 2 problems in the class. Then you can solve 5 at your end. But that 2 problems also will require time. So concentrate more on, you can make some notes, like as I said, chapter 1 is important. Okay, all those conversions are there. Similarly, 2.2 is also important. You will get many questions from this 2.2 and it is easy to score. Okay, so again around 10 to 12 marks weightage from this particular chapter. The third, again an important topic, and you can see it is 10 hours. Okay, so 10 hours, 20 to 25 marks. So majority of the weightage is from your chapter number 3. Okay, so here what you will be seeing is again 3 part 3.1, 3.2, 3.3. So the number of hours are also mentioned, but again we will be requiring more number of hours. So the first one is your SOP and POS representation. Right now, if I tell you what is SOP and POS form, you will not understand, but it is a minimization technique. Like previous module had this Boolean algebra and De Morgan's theorem. So I give a big equation, you apply all those De Morgan's law and you reduce it to a simpler form. Similarly here, suppose I give you a very big equation, A multiplied by A added by this and so on. So here you have 2 representation, SOP and POS representation. Okay, and we go up to 4 variable, that is 4 inputs, A, B, C, D or X, Y, Z, W. Will not go more because the complexity will increase. So we have the McCluskey methods of minimizing that expression. Okay, so our aim again in 3.1 is I have a very big expression which has only multiplication and addition. Division we are not going. Subtraction also we usually don't have the notation. We have addition and multiplication. So I have to reduce it. So एक बड़ा equation रहेगा and then they will specify either you use SOP form or POS form, and a K map है, a table is there. No need for some formulas or something. Rectangular table है, जैसे वो सुडोकू खेलते हो, there is a table and you fill up all the details. So you fill up in K map and then you can reduce it. Okay. Then comes the 3.2, the circuits, the arithmetic circuits, like half adder. Half adder, like if you are adding 2 numbers, then a carry is generated and all. So here it is a half adder. Half adder circuit means it does not give you a carry. Full adder is there. Then you have something, then if I want to subtract 2 things. So we have the half subtractor, full subtractor, look ahead adder, and the BCD adder. We are studying BCD code, so we are studying the BCD adder. Then we have the magnitude comparator. See, all this digital design we are doing for computers, and you know computer does, no, you write no 2 plus 3, 5, how that operation is. So we will be studying the circuit. Now this adder circuit or subtractor circuit हम किससे बनाएंगे? Logic gates, which we have already covered in module number 2. So you have NAND, or AND, or XOR, NOR. So all those logic gates are there. So once I have the formula, first we will derive the formula using this K map, and then we will implement that circuit using your logic families. Then magnitude comparator. Okay, so if I give you 2 numbers, whatever is the circuit, output should decide whether it is bigger or smaller compared to the previous number. Then you have multiplexer and demultiplexer circuit. Now, can you hear me properly? Now, what is multiplexer and demultiplexer circuit is, see, we have so many channels that is going on in space. We are transmitting all those signals in space, and at your receiver end, what you do, you tune into a particular channel, you get that function. This is Sony TV has, Z TV has, Star Plus has, so many channels, they are available at a particular frequency. Whichever you want to listen, you tune to that. No, remote se wo channel means you are selecting that particular channel. Now, why? How is that transmission done? At the transmitter station, you look kya karte hain? Many channels are there, many signals are there. They multiplex it together and they send it through one particular lane. अलग अलग चैनल के लिए अलग अलग सैटेलाइट रहेगा, ट्रांसपॉन्डर रहेगा. It is not like that. So at the transmitting end, many signals are there. You combine all those signals and make a single signal, and then you transmit that single signal. अभी at your receiver end, suppose your TV है या मोबाइल में है, तुम FM channel सुन रहे हो. So you have many signals coming because there is an antenna both the place. So what we need to do, I have a combined signal now coming to me. Now that combined signal I need to demultiplex. पहले multiplex किया और भेजा. Now when I'm receiving that, what I need to do, I have a combined signal. मुझे सारा combined signal नहीं चाहिए, मुझे एक ही चाहिए. So what I need to do is I need to demultiplex it. Okay, understood? See this, whatever you are studying, next time you will have principle of communication. So the circuit you are studying it now, और वहां पे से block diagram रहेगा. So what is inside the circuit you will study in this particular subject. So you will know how to multiplex a particular signal, means you will combine the signal, then how you will cascade the multiplexer. एक stage में अगर multiplexing नहीं हुआ तो you require the various stage. Then I implement a Boolean function using your mux, demux and basic gates. Similarly, encode. कोई भी signal, when you are transmitting it, you don't want others to see your particular signal. So what you do, using some technique, you try to hide that particular signal. So how do I encode a particular signal? Then similarly at the receiver, I want my original signal back. So how do I decode the signal? So these are all circuits. Okay, whatever we are studying from this part, 3.2, these are all circuits. Okay, so the concept multiplexing, demultiplexing, so directly they will give you many signals, multiplex it, demultiplex it, and draw the circuit diagram. You will study this using various ICs or basic gates. Here, chapter 3, 10 hours, the maximum weightage comes from this particular chapter. So this is your combinational logic circuit. Again, 4th, 3 and 4 are the most important chapters of all the 6 modules. It will be clear as you see the weightage. Combinational ke baad comes the sequential logic circuits, 12 hours. Okay, so here again 3 parts, 4.1, 4.2, 4.3. So here some new terms you will study. Flip-flop. Okay, so flip and flop. From the word flip हो रहा है, flop हो रहा है, on हो रहा है, off हो रहा है. Okay, so something like that. So you have RS flip-flop, JK flip-flops, slave, TD flip-flops. These are all the flip-flops, different kinds of flip-flops you can see. Now, how do I tell you what is a flip-flop? Flip हो रहा है, on हो रहा है, off हो रहा है. Like the first one, RS. Okay, RS is the set reset flip-flop. R for reset, S for set. अभी इसमें क्या हो रहा है? Suppose जैसे तुम्हारा टैंक है, टैंक में you are filling up the water. At a particular level, water is reached. What you would like? You would like the water flow to stop because तुम्हारा टैंक fill हो. तो you might have a mechanism, a sensor. जैसे वहां पे आ गया, you want to stop the water flow. तो तुम क्या कर? Reset कर दोगे. Okay, reset means stop हो गया. हाँ, because my thing is reset. जैसे computer you switch it on or what you do, you restart. So similar thing, reset. What happens as we use the water, again the water level comes down in the tank and again you want to switch on the tap. So what this set, again there will be a sensor. So that sensor will sense that water has fallen down. So again I will set it, मतलब एक trigger pulse भेजेंगे. So it will again start the water flow. So this is just an application which I have explained. So we will not go deeper into the application because that is your designing part. We will study what is an RS flip-flop. Okay. Then the flip-flop is there. So you have to understand RS flip-flop properly, then becomes a JK flip-flop, then you have master slave, toggle, delay flip-flop. Okay. And the various triggering method. Okay. तो कभी जैसे किसी को positive pulse चाहिए on होने के लिए, किसी को negative pulse चाहिए on होने के लिए. So how this triggering is happening, that we will see. Also, we will see conversion of flip-flop. Suppose I give you a JK flip-flop. How do I convert it to RS flip-flop? So that conversion techniques you need to know. Now, SISO, SIPO, PISO, PIPO. So these are how you give the input and you get the output. Like for example, your SISO. SISO ka full form is serial input, okay, serial output. So you give, when you give your input to a particular circuit, you give your input in serial form, SISO. Okay, so SI. Or output, जैसे you give 1, 2, 3, 4, this numbers you give in your circuit, and at the output, how do you get? You get one first, then you get the second one, you get the third one. And so you give serial input, you get serial output. Similarly, SIPO, P stands for parallel. So you give input in serial form 1, 2, 3, 4, but the output you will get a column form where you get 1, 2, 3, 4, 5 in parallel coming out. So these are the various ways in which your output and input is related. Like you give your output in a particular fashion, how you get your output. PISO is I give input in the parallel form, but I get output in the serial form. Then we have something called as the universal shift register. Okay, so this I'll explain later on. It is how I shift my bits. Okay. Then comes your counters. Okay, so all of us, we use digital watch. Okay, so you know how my counter works. It suppose counts from 0 to 60, and then the second minutes hand is upgraded and all that way. So you will study synchronous and asynchronous counter. Now, along with this, the state transition diagram is important. Then we have up down counter. Up down counter means suppose I count from 0 to 5. 0, 1, 2, 3, 4, 5. Similarly, I have a down counter which will count down, but the 5, 4, 3, 2, 1. Then mod n counter, BCD counter. So various counters here you will be studying. Then here, once you have studied the sequential circuit, you will understand the application of sequential circuit. Okay, so again here frequency division mein kaise you are using the sequential circuit. Then we have again counters, ring counter, Johnson counter, and then little bit introduction to design of Murray and Mealy circuits. So we will be covering all this when we study the fourth chapter. So third and fourth, remember, it is very important. Then the second last one is different types of memories and programmable logic device. You can see 4 R's are there. So it's all theory, different types of memories are there. So you have SRAM, DRAM. So all these are present in your computers. So you need to understand, okay, what are those various memories. Okay, so you have SRAM, DRAM, ROM, ROM, PROM, programmable ROM, EPROM, EPROM. Then we have flash memories. Then we have something called as PLD, that is programmable logic devices. So we will study, so just an introduction, and then programmable logic array, that is PLA. All this you will carry forward in microprocessor, microcontroller when you will study later on, because all this is very at a low level, third semester you can understand, but when you study microprocessor, microcontroller, you will understand all this more properly. Right now it is only the theory. The sixth module comes as your introduction to Verilog hardware description language. Okay, now when I do this simulation programming of digital circuits, we use this particular language, that is your Verilog HDL. So, but I don't think whether we will be able to do, because we require that particular software. Still we will see. So right now, this as a part of theory, I will just teach you what are the basics of that programming language, some syntax and all. And then we can design adder, subtractor, multiplexer, flip-flop. So all those 4 things are mentioned, okay, using your Verilog HDL. Okay, so there are basically codes for this, which we will be giving you. So this completes your Introduction to the syllabus. Okay, so anything else you would like to ask me?
Yeah, ma'am.
Ah,
Yeah.
your voice is very slow. I think you are wearing that Bluetooth. Due to that, I think your voice is
Okay, I'll change it over.
no. Be loud. No.
In this?
Yeah, you tell me. I'll try to hear.
Okay, I'll change this.
You change this. I think that is better.
Yeah, just a minute.